bringing laser scan data in the metaverse. What about mesh streaming in your VR application?
Hi, thanks John. There will be two speakers today. I will start by introducing Cintoo Cloud and what is the challenge of bringing laser scan data into a VR environment. And then Nicholas will be showing you how we do that using Unity or Unreal. Okay, so before going into the topic, let me introduce Cintoo Cloud to you. So Cintoo Cloud is a SaaS platform at the convergence of digital twins and reality capture data. So with Cintoo Cloud, we'll take your laser scan data, being structured and unstructured data or drone data, we'll make it fully cloud compatible, and by making it cloud compatible, we make it fully collaborative, we make it shareable, distributable from anywhere at any time, and this is becoming now something you can use for your engineering and collaboration work. Okay? The problem we're solving here is the fact that laser scan data has been, this is huge data, this is massive data that is very difficult to share. It's a very desktop-centric type of data, so we make it fully cloud compatible now. On the core, the technology behind is this unique capacity that we have to turn point cloud into high-resolution 3D meshes. And we do that prior to the upload to the cloud, so that everything uploaded to the cloud will be mesh-based, about 10 to 20 times smaller in size than the source point cloud, but still retaining the accuracy, density, and structure of the project. So there is no compromise on accuracy by doing this point cloud to mesh transformation. And we can do also the inverse transformation. We can bring back the mesh to the source point cloud data. And once the data is in the cloud as a mesh, we can stream very fast this information in a web browser. People would call us the Netflix for 3D data for this very reason, because we can stream very fast, high-resolution 3D meshes in a web browser. So this is the core technology we have with Cintoo, and we apply that to various industries, being, globally speaking, the digital twin industries. That means car manufacturing, oil and gas, energy distribution, etc. This is what we call Industry 4.0, but also BIM and construction. We started with this industry, so we have big customers, reference customers in all of these global market segments. And there are basically three types of value propositions we have with this platform. The first one on the left-hand side is everything about sharing your laser scan data, accessing your laser scan data via a web browser. You can then enrich that with annotations, measurements. You can organize your scan in various areas of interest, which we call work zones. You can also manage the access to your laser scan data. We have a complete set of user management tools. So we make it, the data that is in the web browser looks like it's a mesh. It's no more a point cloud, okay? So much easier to view and interpret by non-experts. Okay. The second type of value proposition in the middle is what we call QA/QC. We can upload a BIM model or a CAD model. Connecting to BIM 360, for example, is one way to upload a BIM model, or Revit or Navisworks. And then we can compare this model to the existing condition, to the scan data. And we can generate heat maps that will highlight the differences between the scan and the BIM. Okay, then you can document those issues, push back those issues in BIM Track, BIM 360, Procore, and then you do your project coordination, model coordination. And the last but not least, on the right-hand side, is everything around asset management. We can automatically detect equipment and assets inside the scan data, on geolocating, classifying this information, and then we can connect that to digital twin platforms or even IoT platforms. So it's all about viewing assets in their existing conditions and then be able to manage your assets this way. So the way it works is that we would take your laser scan data after it has been registered in various software like, Pharoscene, Leica Cyclone, Recap Pro, etc. We can also import now unstructured data like Navis or GeoSlam or Gexel, whatever, MScent as well. And then we will do this point cloud to mesh transformation prior to the upload. So everything uploaded to the cloud is mesh-based. And then we connect Cintoo Cloud to other BIM or BIM platforms, and soon also to other CAD platforms, to pull models, to push issues. And when it comes to accessing the data for people doing modeling in Revit, they can do that either by turning back this mesh as a point cloud, could be A57 or CP or CS, or using the mesh as well, would be an FBX, OBJ, or STL mesh in this case. So it's all about streaming high-resolution mesh-based scan data into a web browser. And now we can also stream into VR apps like Unity or Unreal. And this brings me to the topic of the day. So the platform is being used by almost 300 companies, global companies worldwide now. They've uploaded more than, we're close to 2 million scans to the platform with 20,000 users, etc. So this is a fast-growing, business for us, and we're very happy about that, of course. So laser scanning on the metaverse, and that will be, why is it an issue? Because when you want to bring in reality capture data, so it means your existing conditions in a VR app today, and you want to bring that as an industrial metaverse, I would say, in order to build all kinds of applications that could be for collaboration, could be for operation, it could be for also simulation, like factory layout simulation, for example, or it could be also for QA/QC analysis. So there are many good reasons why you want to bring as-built data into the metaverse for VR applications. But the problem, I'll say, and also before talking about the problem, everything VR today is mesh-based. And good news is that what we do as well is also mesh-based. So there is a full compatibility here. So the issue we're solving with what we do is that bringing these existing conditions today, so bringing your point cloud or bringing your scan data into, let's say, Unity or Unreal takes a lot of time. You spend weeks turning your point cloud into a real-time compatible 3D model. You always have to compromise between polygon count, size of the texture mapping, etc. So what we do is that instead of doing this, what we do, we stream directly our high-resolution 3D meshes in the platform. Okay, and this is done in real time. So you don't have to spend any minute trying to optimize your mesh-based reality data. It's all there. Okay, and then we mix that with CAD simulations, CAD or BIM simulations. Unreal, for example, has a piece of software called DataSmith that will allow that supports at least 80 different CAD formats. And then from this mix, we create rich scan-on-BIM or scan-on-CAD experiences. Okay, and this is what Nick will be illustrating for you. Just a quick sample here. So the mesh-based scan data is being, I cannot play the video. Anyway, Nick will be showing you a better version of that. So I will leave it to Nick now to show you what we do. This is all using what we call the Cintoo SDK. So you can build your own VR app inside Unity or Unreal using our SDK that will allow this streaming. So the SDK is about authentication first, and then about feeding the app with the right 3D mesh based on the user's point of view in real time. Okay, and this is where I will leave it now the stage to Nick to show you an example of that.
Hey everybody, how do you advance? Just so I know this intro this. Okay, great. Yeah, I'm Nicholas Czarnick, CSM at Cintoo, and I'll be discussing and showing some examples of applications and use cases for streaming mesh-based data into real-time platforms like Unreal Engine. So we're going to be using a sample data set provided from our friends at SSOE Group. And right now we're in the Cintoo project, so I have my Chrome browser open. And I'm just going to show you as an example the sample data set that we're going to stream into Unreal. So right here we're seeing the 2D panel image captured by the scanner at this location. And we can navigate scan to scan. And in a second we can switch from our 2D panoramic image to 3D surface mode. So now we're seeing the high resolution mesh has been created from the source scan data, being streamed into our Cintoo project in the web viewer here. And we also have the ability to switch the display setting from a 3D surface to 3D RGB mode. So now we get the RGB color information coming from the 2D panoramic image overlaid onto our high resolution mesh as a texture. And because this is all 3D data and 3D view, we can display 3D design models overlaid onto our as-built conditions being streamed in as the mesh-based data. So we're seeing a combination of design model and scan data here. So I'm jumping into Unreal Engine, and I'll just quickly kind of go through the workflow of using our Cintoo plugin to stream the meshes. So with the plugin, we can access our Cintoo account and basically authorize the connection between Unreal and Cintoo. And once that connection has been made, we'll see the list of projects under our Cintoo account populate in the toolbar on the left side here. And once those projects are in, we can load a project. It'll bring in the files and the folder structure we've organized in our Cintoo project here in the Unreal toolbar. And then from here, I can select a scan position to begin loading and streaming into the editor window in real time. So now we're seeing the high resolution mesh from Cintoo being streamed into our editor window that we can view and turn our view and see the mesh from different angles. And by default, the mesh comes in with that 3D RGB texture applied to it. So within Unreal, we have the same scan-to-scan navigation. We can jump from one scan position to another. And when we do that, we load in the mesh that's been created at this scan location as well. So one thing I can kind of define here is you do have the ability to, and the flexibility to move the camera within your editor view. You're not locked into that one position, but we do stream one mesh at a time per scan position, and this allows us to display and stream the highest resolution mesh into the editor in real time. So we're seeing the one mesh streamed in per scan position. So next I can show an example. So we're jumping into our VR play mode. So I'm using my Quest VR headset linked to my laptop through a link cable. And now we can see we're immersed in the true scale, one-to-one scale display of our mesh being streamed into the editor. And like the desktop view, we can navigate scan to scan using the motion controller. So we're clicking the scan icon nodes at each location. And then you also have the ability with the motion controllers to hide the color texture. And now we're just seeing the surface of the underlying mesh that's being streamed in from our Cintoo project. And we're seeing that view here in what I'm seeing in the VR headset is being displayed here. So just a quick example of being able to navigate and view the data that's being streamed into Unreal Engine. So I'm going to go through a few use cases and examples. This first one here is showing the use case of being able to enrich the scan data with other 3D models, entourage, and animated construction models as well. So here I'm within my VR view at this one starting scan position. I can navigate and jump to the next view to load in the mesh from this position. And as I navigate and move around, I can get the different viewpoints. I can see what's happening from different areas of this site preparation scenario that we're trying to exemplify here. And we see we have animated construction models and 3D entourage model being pulled into the scene as well. So being able to see those data sets combined. So next I'll kind of go through the workflow and process of setting up a scene to exemplify like a construction phase type of scenario. So again, we're seeing the mesh is being streamed in from our current scan position. So right now I'm dragging in a design model. It's the structural design model that's been imported into the editor through Datasmith. And we're going to place that here and see it placed along with our as-built conditions that are being streamed in as that mesh-based data. So again, I can modify my view, I can navigate and look around and see how this design model and the structure model fits into its as-built and existing condition context. When we can see the design model and the as-built data being streamed in as a mesh. I can navigate to another view to load in another mesh from another scan position and just get different points of view and see how these data sets are aligning and coming in together. So then next I'm going to actually pull in it's going to be a crane, a 3D crane model in preparation for setting up an animation sequence to give an example of collision detection and collision overlap that we can show the as-built mesh interacting with other 3D models that have been placed in the scene. And I'll take a second here to mention that everything that we're seeing in these examples has been done with little to no coding experience. So all these things are kind of out-of-the-box features that come with the Unreal Engine platform and features that you can use without having the knowledge or experience of coding and software development. So it's very accessible. So here I'm just setting up a basic timeline and animation sequence using the sequencer tool in Unreal. And I'm setting up the crane to animate when we enter plane mode. So next we'll jump into, so we have the plane mode and we're in VR view now. And we're seeing the crane model animating based on the sequence that we set up. But the key takeaway here is the ability to show when that crane overlaps with the streamed in mesh, we can detect that collision and modify the color of that crane model to show that there has been an overlap or collision between 3D model data and the streamed in mesh that's coming from our Cintoo project. And this can be applied to more advanced simulations like factory layouts and those kind of use cases as well. So this is the last example here. We want to show visualize the final design in its real-world context. So right now I'm going to bring in the facade design model, so another Revit model showing the exterior facade of the building. And I'm going to place that as well over the structural design model that's already been imported into our scene. So now we have the ability to visualize the final built design in its real-world context and existing conditions as well. And while visualizing designs in real-world context is not a new concept, it's nothing new there, it's this ability to use reality capture data, streaming real-time into a platform like Unreal to provide that real-world context. That's really the next step in where these things are kind of going. And when we talk about this ability to use reality capture data in real-time engines, visualizing and setting up different scenarios and simulations, I think we're just kind of scratching the surface of this convergence between reality capture, what we know as digital twins, and then this metaverse concept that we keep hearing about. So without opening a whole can of worms about the metaverse concept, this idea of not just having virtual worlds that are made up of this metaverse, but being able to incorporate these digital twins or digital replicas of real-world places and spaces and making that part of this metaverse concept is really what excites me about being able to stream in existing conditions and incorporate that into our simulations and different use cases that we can access through technologies like virtual reality. So again, we see this kind of the setup of a visualization that we can see the final as-built design in its real-world context, be able to create visualizations and immersive applications to create buy-in from stakeholders or other users of the project. And then here, just another example of being able to jump from a desktop view to our immersive VR view and seeing the design model and existing conditions together in this kind of visualization of the project. So in this last sample here, I'm going to use another sample data set provided from our friends at Nor Technologies. So here we see the project in our Cintoo Viewer as well. So when I jump into from 3D navigation to scan mode, we can see the complex existing conditions of this power mechanical room that's been captured by the scanner. So when we switch between 2D panoramic mode and 3D surface, you get a really good look at these very complex as-built existing conditions that had been captured on site, and now we have a high-resolution mesh that's been created from that source scan data and that source point cloud. So we're going to jump back into our Unreal Editor interface and show that data set being streamed in to our editor window as well. So again, we're going through the process of connecting Unreal Engine to our Cintoo account and Cintoo projects, being able to select that list from that list of projects, and then selecting the individual files and folders within that project to begin streaming into the window. So now we get that same kind of viewpoint, and we have the high-resolution mesh streaming now into the Unreal Editor. And again, you still have the ability to navigate scan to scan. We're loading in the meshes based on each scan position, and you can see how quickly and efficiently we can stream in this very complex data into an engine like Unreal. This is actually a really good example of the type of existing conditions that you wouldn't want to spend the resources and time to model and optimize for use in a real-time platform like Unreal Engine. So being able to take the high-resolution meshes that we've created and be able to stream that data directly into the editor is kind of our solution in sidestepping the amount of work that goes into optimizing this kind of data. And then this example use case is showing this idea of being able to test fit and clearance check equipment models, different asset models, and pulling those into to the scene to see how they fit into the real world, existing conditions or existing context. So here we have a few equipment models that we're pulling in, and we can quickly, kind of see how they fit into the existing area that we're trying to place them. And then again, we can switch from our desktop view mode into more of an immersive VR view, and this kind of hints at use cases around training simulations, being able to bring in a 3D model of an existing asset and being able to be in an immersive kind of situation where you can interact and run training simulations with that kind of equipment. So yeah, that concludes my video. It's just a couple of just quick examples and use cases of how you can bring in existing conditions to this kind of simulation and those kind of workflows. So thank you.
One quick question for you, Nicholas. So that last section, that last example you were showing, I'm trying to think of like the real world use case scenarios that I would use maybe. And one of the ones that came to mind is like an OR room, doing an operating room where they're replacing the equipment. I know it's a really big deal to be able to test the operation of the lights and stuff, yes, where all the equipment is in the room. A lot of facilities are doing mock-ups, full-size, room mock-ups. Have you guys had anyone like that participate in doing any kind of mock-ups in this?
No one specifically, but that's definitely a clear use case for If you have the reality capture, a scan of an existing operating room, maybe it's empty, you can bring in those 3D assets and models and do that test fit in a virtual setting and not have to do the physical mock-up of that. You can save those resources and time, and you have the flexibility of using a digital environment to test those kind of things.
Great. Yeah, and just like there's so many new tools out, and first becoming aware of them, right, and what they can do, and then you got to figure out what use cases they're practical for. And this was really fascinating. Thank you so much.
Thank you.
All right.
We don't use stationary scanners, we use walking scanners. So you've got positions where your scanner is collecting data, and so you don't really have timestamp issues. I'm curious if timestamp data makes it over from your conversion to mesh when you bring it into Unreal.
Are you talking about scan data that's not static structured data, but
That's
more
correct.
for the mobile?
You're collecting a series of scans while we do a walking scan, so it's collecting actively. And therefore there's timestamps along with our scan data. And those timestamps matter when we want to link up with other data sources to coordinate. So if that comes in, that's a real asset.
Yeah, so the way we kind of handle unstructured data with Cintoo now is you actually have the ability to select which of those locations along your scan path you want to create as your scan locations within the project, and then you can be able to stream in the meshes created from those positions into an application like Unreal to get that data.
Gotcha, so that'll definitely be part of it. Cool.
Hey, Dan from Deep Scan Studio. So a couple of questions I had was, I guess you guys had mentioned that the meshes that are kind of in the VR realm, those are derived sort of instantaneously from that particular scan.
Yes.
Correct? So it's not time scans that might have, created the warehouse. It's from that one scan.
From that one scan, yeah.
And then you get the mesh. Why not have like all the scans, or at least a larger portion of them registered, or meshed, so that there's a little bit more of an environmental, that there's more of an environment for you to move through. Because I can imagine in a large warehouse, you probably take not just one scan, but a series of them.
Mm-hmm.
And so having those scans meshed would be probably a lot clearer data, and it would be almost like a video game. You could kind of walk through and all that. So is there, do you guys do that, or?
Yeah, so that's what we're looking to incorporate next.
Okay.
Being able to have that free move capability.
Yeah.
As you move your camera or your VR character through that scene, be able to know which scan locations to load based on where you're moving. So that's kind of how we're approaching being able to get that free move capability and not just be tied to seeing the one scan per location.
Gotcha. And then I think you might have touched on it with like SLAM technology. That's not scan by scan based, but you could decide, hey, from this location, how much data is going to be converted into a mesh, right?
Yes. Yeah.
Okay.
Yeah. You kind of decide which areas along that camera path you want to create those scan locations, and that's how you get the meshes created from that data.
Okay. And then my final question is Unity versus Unreal. Both, I'm assuming you have a preference for Unreal as opposed to Unity. What are kind of the pros and cons of each one? Because since it's compatible with both.
Yeah, I think, right now most of our focus has been on Unreal because we were an Epic Grant recipient back in 2020.
Okay.
So we've been kind of pushing our development more towards integrating, having a direct plugin for Unreal. But both platforms are great. Unreal, probably more for the higher fidelity, better graphics, higher end looking kind of visualizations. Unity is definitely more user friendly. I think it's more accessible to those who don't have coding knowledge or specific knowledge around using game engines or real-time platforms. But both are really solid platforms.
Okay. Oh, and Oculus or the other one, the HTC?
There's HTC, yeah.
Yeah, is there a preference for either one? I know one's more Facebook, you know,
Yeah.
owned, the other one's
So
not.
the best part about so the Quest, so that's the Facebook Meta
Yeah.
hardware. There's really no competition right now for standalone, affordable, ease of use and that kind of thing. So that's really the benefits you get with more the Oculus Quest and that kind of hardware. But then I say HTC, the Vive, they've been more focused on kind of enterprise and business customers. But even though there's a lot of stuff around Facebook Meta, the Quest is definitely the target kind of platform right now for most applications.
VR stuff.
Yeah.
Got it. Okay, cool, thanks.
Great, thank you.
All right, I think that's kind of a little over time, but I think that was, those are some great questions. Thanks so much.
Thank you, John.
Appreciate it. All right.